At the same time, I'll present my. So first of all, tell me what is in the comparator.
Comparator is a combinational circuit which used to compare.
Which is used to compare. Okay, so that means suppose we have two inputs. So comparator is the circuit which will compare that two inputs, and depending on whatever is the value present in each of these on each of these input lines, it will give us a signal. Okay, so it may be either greater than, or it may be less than, or it may be equal to. Okay, so that means actually whenever we are considering any two numbers, so that time it may be greater than another one, or it may be less than or equal to. So these three conditions that may be present in any of the comparators. So we are going to write now VHDL code for this comparator circuitry. Okay. So as we know that the comparator, that is a digital circuit which is nothing but a combinational circuit which will compare two inputs, and then depending on whatever is the value present on these lines, it will give us a signal that is a greater than or less than or equal. Okay. So that means we will have two input ports for this comparator. Okay. So there will be two inputs for the comparator circuitry. Let us say A input and B input. Okay. So these are the two input signals, and then there will be three output signals. Okay. One is the greater than, the another one that is a less than, or third one that is equal to. So depending on the comparison, any one of line output line that will be at a high logic level, and others will be at a zero logic level. Okay, so we are going to design a circuit in such a way that if A is greater than B, then greater than will be at a high logic level, and less than and equal to that will be at a low logic level. If A is less than B, then less than that output that will be at a high logic level, and greater than and equal to that will be at a low logic level. And if both these numbers are equal, then equal to will be at a high logic level, and others will be at a zero logic level. Okay, so such a circuit that we are going to design. So that means now we have in an entity our input ports are two ports. One is the A and another one that is the B, and output ports that are three. One is greater than. So for that I will use the convention that is a greater. Then one is less than. So for that I will use less, and third one that is the equal. Okay. So that is the equal to. So these are the three ports for this uh, comparator circuitry. So I'll share my Xilinx ISE window. Okay. So this is the tip of the day. So I will close this and let us go for the next. Okay. So now I will just create a new project. Okay, and I'll give the name to this as a comparator. Okay. And let us have a comparator 4-bit comparator. Okay. So I'll give it as a comparator 4-bit. This is the name to this project. Okay. So next. Okay. So uh, these are the settings for this project. So we have selected family, that is the Spartan 3E, then device XE3S500E, and then package that is a V200, Then we have selected preferred language as a VHDL and so on. All these settings that we do in the earlier program, the same setting that I have done. Okay, so here you will find a project summary and then let us finish. Okay, okay, I have given the name as a COMC. Okay, let it be. That name will not affect our program. Okay, so now I'm going to have a new source in this project. So this is the VHDL model that I have selected, and I will give the name to this now, comparator. Okay, comparator. Oh, spelling mistake. Comparator, and it is a 4. Okay, so comparator 4. That is the name I have given to this comparator that I am going to design. Okay, next. So now here, as I am going to have a 4-bit comparator. Okay, so the input, that is the A input and B input. So these are the 2 inputs. But as I am going to have these inputs as a 4-bit, so I will select a bus. Okay, so here MSB will be 3 and LSB, that is a 0. Okay, so that means A input, that is A is the input port which is 3 down to 0. Also B is the input and MSB that I am going to select as a 3. So that means it is a 3 down to 0. So 4-bit A and B inputs, these are the 4-bit inputs. Okay, and then let us have output, that is a greater GR. This is the output port. Now this is a single bit, so no bus selection will be there. Then LS, that is again a output port. My window is visible to you? Whatever I am doing? Hello?
Yes, ma'am.
Yes, ma'am.
Okay, so this new source wizard window is open. Okay, because I can't see it on my mobile.
नो मॅम ते दिसत नाही आहे.
नाही ना दिसत आहे?
हा नाही दिसत आहे.
नाही मॅम, आपली इनिशियल जी साईड असते तीच दिसते मॅम.
फक्त ब्लँक साईड दिसते ग्रे कलरची.
हो मॅम, तीच दिसते.
ओके, तुमच्या लक्षात आलं असेल की आपण एक विंडो ओपन होते जेव्हा आपण सोर्स ओपन करतो की एनटीटी साठी, एनटीटी मधले जे काही तुमचे इनपुट आणि आउटपुट पोर्ट देणार आहे त्याच्यासाठीची, तर ती ओपन आहे आणि ऍक्च्युली मी तिथे चेंजेस करते. ठीक आहे, बट आय डोंट नो वाय दिस इज नॉट ओपन हियर. ओके, okay, so what I'll do, instead of sharing just a window, I will share a whole screen. Okay, so that it will be clear to you. So I'll just stop sharing and then I'll just once again share my entire screen. Okay, now is it visible?
Yes, ma'am.
Okay. So what I have done, I have used input A, okay, which is the input port, name given is a A, which is a bus. That means it is, I am going to use it as a standard logic vector which is in the range 3 down to 0. So MSB is 3 and LSB is 0. B input is also input port and it has the MSB that is a 3 and LSB as a 0. So this is also a bus. So that means this is a 4-bit inputs. Okay, A and B, these are the 4-bit inputs, and then GR, LS, and EQ, these are the outputs. Okay, so these are the single-bit outputs. So either 0 or 1 will be present on these output ports. Okay, so let us go for the next. So this is the summary of this source, and then let us finish. Okay, so here you will get a when this HDL code, okay, so this is actually the skeleton, okay, whatever is automatically generated code, okay, for this entity that we have written, okay. So this is the part that is the library declaration. As usual, it is there. Then after that, we have entity declaration where all the ports that we have defined earlier, so that are present here, A and B input, which are the input port, and it is of the type standard logic vector, 3 down to 0, that is a 4 bit. And GRLSEQ, these are the output ports, which are of the type STD underscore log. Okay. So this is the end of this entity, and then after that, we are going for the architecture. Okay. So architecture for this, I have a name given to this architecture, that is a behavioral, which is of the entity, that is a comparator underscore 4. Okay. So now we will start writing this code, architectural code. Okay. So whatever is there, that we will write. Okay. So now whatever statement that we are going to have in this architecture, that we want to execute in a sequential manner, okay, and that is why we are going to write a process. Otherwise it will be processed in a concurrent manner, and that we don't want. We want to check it one by one, and that is why we are going to write a process. So let us have a process, and then sensitivity parameters in this, that is the inputs that we are going to consider A and B. Okay. So this is the process, and let us begin with this process. So now what we want, if A is greater than B, then we want GR that should be equal to 1. Okay. Then we want LS that should be equal to 0, and EQ that should be equal to 0. Okay. Now else if A is less than, sorry, this is less than condition, no? Okay, sorry. So here it should be, GR should be 0 and LS should be 1. Okay. Now if A is greater than B, then, okay, I'll just copy this so that my time will get saved. Okay. I want now GR that should be 1, LS that should be 0, and EQ that should be 1. Or else if, or you can say else. Okay, so just add this. Is equal to B, then GR should be 0, LS should be 0, and EQ that should be 1. Okay. So end of this if statement, end of process, and end of this architecture. Okay. So this is the very simple code for this comparator. Let us save this. Okay. So I have saved this, and let us check for the syntax. Okay. So syntax is also correct. So let us now view RTL schematics. That means if you are going to have a IC of this code, so how it will look from the outside as well as what will be the internal circuitry that we are going to check. So these are the pins. Okay, so here this is the bus which is a 3S to 0 and A, B that is also 3S to 0 and these are the two outputs. Okay, so if you click on this, then you will get a internal circuitry. Okay, so this is the RTL schematic for this comparator. Let us close this and then we are going for the writing a test bench for this circuit. Okay, so let us go to the new source again. Now we want to write a VHDL test bench. So click on this option, that is a VHDL test bench, and then write a comparator. Give a name, okay, whatever you want. So I am giving comparator underscore 4 underscore CV. Click on next. Now here you will find all the sources that are present in the given project or whatever project you are associated with. Now, there is only one source, so we are going to associate our test bench with that. So select that one. By default it will get selected actually. So then click on finish. Okay, you will get the summary. After checking for the summary, you can finish it. And then you will get again a automatically generated test bench code for the entity or for whatever VHDL code that you have written. Okay, so now here library declaration part that will be there. Then in an entity declaration part, there will no any port declaration part will be there because we are going to instantiate a component. Okay, so that component declaration part will be there in an architecture body. So in architecture, you can see here whatever ports of these components that are listed. Okay, so then after that, you can see here we are going to assign signals there. Okay, so all the signals A input as well as B, these will be considered now as a signals here because we are instantiating component आणि त्या component चे input इथे आपण as a signal म्हणून consider करणार आहे या unit मध्ये. So we are going to initialize these inputs as a signal. So here you can see that signal initialization part and then initial value for all these inputs that is a 0. Okay, so after that output signals that are assigned here. So all these signals that are assigned as a all these outputs that are we are assigning as a signal. Now as we don't want a clock in this, so I will just comment it. You can delete it also, no issue. Okay. Now after that, in a big actual architecture body, we have a port mapping. Okay, so whatever is your unit under test, okay, which unit you are going to test here. So all the ports of this unit will be mapped to the component port. So we are mapping here A to A, B to B, GR to GR, LS to LS, and EQ to EQ. That means all input ports will be mapped to input ports of this unit under test, as well as all the ports of the component, output ports of the component that will be mapped to the output port of this unit under test. Okay. म्हणजे काय आहे की जे तुम्ही काही आधी VHDL प्रोग्राम लिहिला त्याच्यासाठीचा एक कंपोनेंट आपण इथे इन्स्टन्शिएट करतोय म्हणजे इथे आपण कॉल करतो. ओके, इन अनदर वर्ड वी कॅन से दॅट वी आर कॉलिंग इट हियर. आणि मग आपण आपला जो कंपोनेंट आता इथे टेस्ट करणार आहे तो आणि तुम्ही जो कंपोनेंट कॉल केलेला आहे त्याचे पोर्ट्स मॅप करून घेतो. म्हणजे दॅट इज वी आर ऍक्च्युअली we are testing the same, but here we are writing a different code. Okay, so now we have here a clock process, but as we don't want it, I am going to delete. Okay, so just I have deleted, and after that we have a stimulus process. So we want to now give a certain different inputs. So let us have A input. Okay, I'll just minimize this time period. I'll make this at 10 nanoseconds. And I'll make A equal to, okay. So as this is a vector, so you have to assign values in a double quote. So let us say I'll have the value for A as a 1010. Okay, so this is A. Then I'm going to assign B as a 1001. Okay, I just copied this same. And make this as a 010. Okay, just make this, and then so here I don't want this statement also because I am not using clock, so I will delete it. So this is my test bench code. Okay, so with this statement, what is going to happen? If A is equal to 1010 and B is equal to 001, so that means which output is going to be high? Yes, which output will be high? If A is equal to 1010 and B is equal to 1001. कुठला output higher?
A
is greater than B.
A is
This
greater
condition will be
B.
true. Okay. म्हणजे
Yes, ma'am.
GR will be high. बरोबर आहे?
Yes, ma'am.
Okay. In the next step, what will happen? A is equal to 0010 and B is equal to 1001.
A is less than B, ही condition true असेल आणि LS
Will be high.
equal
Yes.
to 1 असेल.
LS will be at a high logic level and all others will be 0. And for the next, A that is equal to 1010 and B is equal to 1010.
A equal to B ही condition true होईल आणि EQ is equal to 1 or all others are equal to 0.
Yes, yes. Okay, so let us go for the simulation. Okay, so let's click on the simulation. Here view, in this view, you have to select a simulation and whatever test bench you want to simulate. Okay, there are some errors. Okay, so it is a this. Okay. Okay. Now there is no any error. Let us check the syntax. Okay, that is also correct. So here, I'll just expand these. So here you can see that initially all the inputs that are 0, 0. So as these are equal, 0, 0, both are 0, 0. So EQ is high and others are at a 0 output logic level. All others outputs that are 0. Okay. Now after that, I have made A is equal to 1010 and B is equal to 1001. So you can see here GR is at high logic level and LS and EQ that are at a low logic level. Okay. Now after that you can see A is 0010, B is 1001 and then in that case you can see LS is at high logic level and GR and EQ that are at low logic level, and then we have made 1010 value for A, 1010 for B. Then in that case both are equal, so EQ is high and GR and LS, these are at low logic level, so that you can check here. Okay, so this is the comparator circuit. Okay, so this is the code for comparator circuitry. Now if you want to change the color of these output signals, okay, you can just go click on that output, just right click, and then you can change the signal color, whatever color you want, that you can change. So let us say I will take GR as in a red color, LS in a blue color, okay, this sky blue color, okay, and then EQ. Let us have this yellow color. Okay, so these are the different colors that you can select for. Okay, there are so many other options so that you can have. So here this is the simulation of the VHDL code for comparator. Okay, if anybody has doubt in this, yes, this is a 4-bit comparator. कुणाला काही डाऊट आहे का?
No, ma'am.
No, ma'am.
So this is a very simple code. Okay, आता तुमच्या लक्षात येत असेल की जेव्हा आपण टेस्ट घेतली होती, ओके, बऱ्याच जणांनी या कोड मध्ये खूप सारे घोळ घातले होते. ओके, म्हणजे जेव्हा तुम्ही वेगळे वेगळे बीट कन्सिडर करता, खूप लोकांनी असं केलं होतं की प्रत्येक बीट सेपरेटली कम्पेअर करण्याचा प्रयत्न केला होता आणि त्याच्यासाठी मग अँड गेट ऑर गेट असं काही काही यूज केलं होतं. देर इज नो नीड टू गो फॉर दिस. VHDL will check all the bits simultaneously and then it will give a signal. So there is no need to check for the single bit. Okay, so you can directly any किती लेंथचा जरी तो तुमचा नंबर असेल तर तो तेवढा बिटचा नंबर चेक केला जाईल. तिथे तुम्हाला सेपरेटली चेक करायची गरज नाहीये. आणि तुम्ही तसं जर करायला गेलात तर तुमचं लॉजिक मे बी करेक्ट येणार नाहीये बऱ्याचदा आणि त्यामुळे तशी करायची गरज नाहीये. So just use this simple code to write a comparator circuit. Okay, आता आपण याच्यामध्ये थोडासा चेंज करूयात की आपण याच्यामध्ये एक एनेबल इनपुट ऍड करूयात. ठीक आहे, आता एनेबल इनपुट ऍड करण्यासाठी आपण काय करूयात, आपण ही जी आहे वेवफॉर्म विंडो that we will close. Okay, I don't want to save these changes, so I will click on no. Okay, and then I will go to the VHDL. Okay, and I will add one input to this entity, so en, okay, which is the input, and this is a std underscore logic type. Okay, so this input that I have added in this entity. Okay, म्हणजे मी आता काय केलं, एनेबल करणार आहे. जर माझं एनेबल हाय असेल तरच हे चेक होईल, अदरवाईज काय होणार आहे, तुमचं सर्किट हे रिसेट कंडिशनला असेल. ओके, so that's one option that I am going to add in this. Okay, so now let us go to now this. Okay, so here now I will sensitivity parameter, one more parameter that I am going to add, that is the en. Okay, कारण याच्याप्रमाणे पण माझी प्रोसेस चेंज होणार आहे. So I am going to add this parameter also in this sensitivity list. So now let us say if en is equal to 0, then here will be assigned to single quote should be there. Okay, 0. Okay, then okay, I'll just copy this again once again. LS will be also equal, we are going to make it as a 0, and EQ that also we are going to make as a 0. Else if Okay. So instead of going for this, let us do this. Is it if A is greater than B? Okay. So we'll save this. Okay. I will just put then. this is the code. Actually, I forgot to write this one in a single quote, and that's why there was a error. So now I have corrected it, and so my check there is no any error in this code. And then this is the schematic, RTL schematic. Now we have added one more input to this, which is the which is going to enable this chip. Okay, so if this input enable input is high, then only you will get output. Otherwise, if this enable is zero, all outputs will be at a zero logic level. So that we are doing here. Okay, so now let us close this schematic and just we will. So we will now have one more source, okay, which for the test bench for this comparator with enable, which is a 4-bit, and this is a test bench. Okay, so we are going to associate this with our earlier entity only because we have done changes in that. So I will select this as well, associate that source only. Next, and then finish. Okay, there is certain error. Okay, I will just open this once again. Okay. So, okay. So initially En is at a 0 and others inputs are also 0. So that time we are going to get this all these outputs that are 0. So this clock signal that I am going to delete now. So all this port mapping is there. This process for the clock that I also am going to delete because we don't want this. And then let us make this period smaller. Let's have a, okay, now we want to have the En that should be assigned to 1. Okay, now as this is a single bit, so assign that value in a single quote, and then A that we are going to make it as a, let us have 1010. B, I forgot to give 0101. Okay, so that means it will be greater than. Okay, then I will just copy this. We'll wait for 10 seconds. Okay, so I have instantiated some values, or I have given a stimulus to all these inputs. Now once I have made this enable as a high signal, after that no need to just go on changing this. So I have done changes in the values of A and B. Okay. So let us go for the simulation, and now I have to select this. Okay. So this is the test bench code. Now that I want to check, let us check for the behavioral check syntax. Okay, I have not saved these changes. So let us first save behavioral check syntax. Okay, it is correct. And then simulation. So initially, you can see here, as the enable is 0, all the outputs are 0. Now in an earlier case, you must have seen that though inputs are 0, 0, but when the enable signal was not there, so EQ was high because the inputs are same. But now, till we are not making EQ, EN is equal to 1, it will not give high signal at any one of the outputs. So all are at a 0 logic level. Now, whenever there is a in A is 1010 and B is 0101, so that time as A is greater than B, so GR will be at a high logic level, other will be 0. Okay. Now here A is 1000 and B is 1100, so LS is high, others are 0, and for 1010 and B is also 1010, EQ is high, others are 0. Okay. Now if you make EN 0, then all will make 0. Okay. So I will just change that. Okay, I will just add EN is equal to for 10 nanosecond, and I will make 0. Okay. Just to check what we are going to get, I will just assign certain values for A and B here. I have forgot to give a semicolon. Okay. आता तुमच्या लक्षात आलं असेल की मी इथला सेमिकोलॉन विसरलं तर माझी इकडे एरर होती. ओके. सो लेट अस टेक द zero syntax. Okay, that is correct. And then simulation. तर इथे तुमच्या लक्षात येईल आता आधीचे जर कंडिशन्स तशाच आहेत. इथे LS ग्रेटर दॅन मोड हाय आहे, नंतर LS हाय आहे, EQ हाय आहे, डिपेंडिंग ऑन द व्हॅल्यू. But now, though here these values are different, but when we are making EN equal to 0, all the output signals are at 0 logic. Okay, so that means till we are not making enable equal to high, you will not get any of the output signal at a high logic level. All will be remain at a 0 logic level. Okay, so this is the 4-bit comparator circuit with enable as well as without enable that we have seen earlier. Okay, so if you have any doubt, you can ask regarding this circuit and regarding this code. Yes, any doubt? Sheetal? Okay. Does it mean that you understood all the things? Okay. One more thing. How many of you have laptop? That was my earlier question. Okay, nobody answered, but still I have shared Xilinx ISA link in your study material sheet. Okay, but as you know that this I have shared links for the OS 30, that is a Windows 7 as well as for Windows 10. But that will require a large size because it is nearly about 8 GB. So there is a one more software that is a model sim. ओके मॉडेल सिम मध्ये तुम्ही परत तिथे VHDL किंवा व्हेरिलॉग प्रोग्रामिंग करू शकता आणि त्याची साईज आहे ती कमी आहे. तर तुम्ही अल्टेराच्या साईटला गेल्यानंतर तिथे त्याचं मॉडेल सिमचं स्टुडंट व्हर्जन डाउनलोड करू शकता. ओके त्याच्यासाठी फक्त तुम्हाला तुमचं कॉलेज लॉग इन मधून लॉग इन करावं लागेल आणि तुम्हाला त्यांचं स्टुडंट व्हर्जन जे आहे ते फ्री ऑफ कॉस्ट मिळेल. त्याचं लायसन्स पण तुम्हाला मिळेल. ओके सो दॅट विल नॉट रिक्वायर लार्ज साईज आणि त्याच्यामध्ये तुम्ही करू शकाल. फक्त त्याची प्रोसेस थोडीशी याच्यापेक्षा म्हणजे Xilinx ISA पेक्षा वेगळी आहे. पण वन्स यू गेट यूज टू दॅट यू विल बी अवेअर ऑफ हाऊ टू डू दॅट अँड दॅट विल बी व्हेरी सिम्पल देन. एकदा तुम्ही करायला लागलात की सगळ्या गोष्टी सिम्पल होत जातात. म्हणजे जोपर्यंत आपण त्याला बघत नाही किंवा त्याला करत नाही तोपर्यंतच कुठलीही गोष्ट अवघड असते. एकदा करायला लागलो की सगळं सोपं होतं. ओके तर त्यामुळे तुम्ही ते सॉफ्टवेअर डाउनलोड करू शकता की जोपर्यंत तुम्ही कॉलेजला येत नाहीये आणि तुमचं प्रॅक्टिस होत नाहीये. ओके सो यू कॅन टेक डाऊन दिस मॉडेल सिम बाय अल्टेरा. अल्टेराच्या साईटला जा. ओके जस्ट टाईप इन अ गुगल इज अ व्हेरी गुड गुरु. ओके तर तुम्हाला सगळ्या इन्स्ट्रक्शन देईल तुम्ही कसं तिथपर्यंत जायचं. अल्टेरा टाईप करा अल्टेराचं मॉडेल सिम. ओके आणि तिथे स्टुडंट व्हर्जन म्हटलं तर तुम्हाला ते डाउनलोड करता येईल. Okay, if possible, I will share that link to you. Okay, if possible today. So you can download it. It will not take more than 2 GB, I think. Okay, so it will require less space. तुमचा डेटा पॅक पण खूप नाही चालणार आहे त्याच्यासाठी डाउनलोड करण्यासाठी. तर तो आपण त्याच्यावरती आणि शिवाय मग जर तुम्ही डाउनलोड केलं तर ते कसं यूज करायचं तर ते आपण नेक्स्ट प्रॅक्टिकलला बघूया. ठीक आहे. कुणाला काही डाऊट आहे याच्याबद्दल? ज्यांना पॉसिबल आहे ज्यांनी Xilinx इन्स्टॉल केलं असेल त्यांना तर काहीच प्रॉब्लेम येणार नाहीये. पण ज्यांनी नाही केलंय मॉडेल सिम ज्यांना करायची इच्छा आहे तर त्यांच्यासाठी आपण करता येईल. ओके सो इन द नेक्स्ट सेशन we will discuss more about practicals related with this VHDL. Okay so till then we will stop here for today. In the next session we are going to discuss some more circuits in this practical session. Okay so you can leave this meeting for today.